Hello everyone, welcome to Amiga Tutors. This video is based on descriptive statistics, and for giving some real life examples we'll use COVID-19 data on Excel. Hope you will find it interesting. So statistics can be classified into two different categories. First is descriptive statistics, second is inferential statistics. So descriptive statistics is like to summarize the data in an effective manner so that we can get the important aspects of it. So it covers those measures like mean, median, mode, standard deviation, then percentile, etc. And inferential statistics is like to estimate or forecast a few measures on the behalf of the large amount of data using a part of that. There are two concepts under inferential statistics: population and sample. So population refers to all the elements of a specified group. For an example, if there are 100 students in your class, then all those 100 students shall be considered as an element, and considering all those elements together shall be referred as population. On the other side, if you are asked to pick any 5 students out of those 100 students randomly, then those 5 students shall be considered as sample, which is the subset of that population. There are three major concepts under descriptive statistics. Those are measures of central tendency, measures of dispersion, and measures of location. So, measures of central tendency helps us to understand where the data is centered. Measures of dispersion tells us how the variability of the data in respect to mean, and measures of location tells us like the distribution of the data. And for those, we use these different tools. So now we can start working on that COVID-19 data. For that, we have to import it. Uh, so we can go to Google, type COVID-19 data GitHub, click on it. So we shall go for the first link, click on it. Then the second one, which is data. So you'll find there are multiple links, but we need the time series one, which is the COVID-19 combined. The fourth one, click on it. Then go to download. Once you click on the download, you will find the data is structured in a particular way. So it has the first column which constitutes of the dates, then the countries, then state or province, then latitude, longitude, confirmed, recovered, and deaths. But we will work on not on all those columns. We just need uh, maybe the last three columns and the country and dates. So we'll copy the link. We'll go back to Excel, go to data, then click on get data from other sources, then click on from web, then paste your URL over here, click on OK. So it will throw a box where we shall have three options either to load or transform or to cancel, but we don't need to transform it, so we can click on load. Once we click on load, then it will open it into a separate sheet itself, and we just got our data. So here we have those columns, but as I told, we don't need all those columns, so we can remove whichever we don't need. So like this one, we don't need latitude, longitude, we can delete. Even we can just work with the column C confirmed, so we can delete recovered and death also. So once we delete it, then I just wanted to show you this data is for all the countries. So you see there are 23,000 rows and it has all the countries, but for now we will work on a particular country, which is India. We can ignore other countries currently. So let's take the data somewhere separate, just paste it, sorry, copy it. So one more important thing which I want to highlight, so if you see this confirm, so these numbers are cumulative. For an example, on 31st of Jan 2020 we had only one case. After that, if you see, on 3rd of Feb we had three cases. So every time it is three because so what does it mean? Like, it was three cases till 2nd of March. So then it got added by two cases, and then it became five cases. So these five cases includes all those three cases plus new two cases. So the numbers are cumulative. This 28 cases includes the new 23 cases plus the five old cases. So what we have to do, we need to calculate the daily confirmed numbers, not the cumulative one for that. So for better understanding, I will show you by drawing a line chart. If you see the line chart, you will understand the numbers are going up exponentially, and it means, like, these are the cumulative numbers. So on this day, it is 15,722, and it includes all the previous numbers. But we need daily numbers. So now we have to calculate the daily number of confirmed cases. So that is nothing but the difference between two consecutive days. So once you get it, so for better understanding, what we can do, so now we can draw another line chart and see the same thing. How is it looking? So now you look at it. So this one was cumulative, this is daily, and so this is how it looks. If you look at the data, you will understand that the data is quite volatile, and in order to measure the volatility, we have to use standard deviation, which we'll calculate shortly. Before that, let's calculate the other measures. So for our own, to make the life easier, we can make it a table, the entire thing. And we can name the table something like COVID. So now we'll start calculating those measures. So I'll go back to the PPT from where I started to show you. So we completed till here. So next thing is mean. Mean comes under the as a mean is considered as one of the measures of central tendency. So it tells, this is nothing. If you see the formula, there are two types of means. The first one is population mean, second one is sample mean. So as I told you, the population is the now when all the elements are together in a group, then it is called population. So for us in this data, if we consider from here to till here till the end, till 18th of uh, April, this data can be considered as population. Okay, and for sample we can take maybe the last few days, like from 6th April till 18th April, we can consider it as sample. So if we are interested to calculate the population mean, then what formula we have to use? We have to use the sum of the elements divided by n. So this population mean is denoted by the letter mu, Greek letter mu, and then this numerator shows like the sum of all the elements divided by the number of elements, n number of elements. And for sample mean, what we do, the same thing we do, we call it with x bar, and we do the same thing. So here, instead of taking all the elements, we just take the sample elements there. So we add them up, and then we divide by the number of samples. So the same thing will perform here. So mean, and this is population mean. So what we can do, can. So there are two ways to solve it. First, I will show you the longer way, the lengthier way. Then we'll go to the shortcut. So take the sum, then divide it by the count. So okay, I will show it separately. So let's take the sum of the elements. This is a table, and we are interested on the last column. So this is the sum, and then we need the count, the numbers. So there are 88 number of elements, and this is the sum. So mean is nothing but sum of all the elements divided by the number of elements, which is 178. So instead of doing this, in Excel we have direct function for calculating the mean, which will be nothing but average. Okay, this forward. Fine. So this was our sample mean. Then this was our population mean. So we have sample mean. So for sample mean, if we are asked to calculate the mean for this number of days, maybe for the last few days, then simply we can just select this many dates and we can calculate the mean. So Excel, we already have a function, we don't have to calculate it. So if you see here, once we select those numbers, we get 946 is the mean for from 8th April to 18th April. Then the second measure is median. So what is median? The definition says median is the value of the middle item of a set of items that has been sorted into ascending or descending order. What does it mean? If you look at the data, we have the data not in any order. It is not following any order. Last number is 1370. Before that we have, so something is so these are not following any particular order. So for median, we have to keep it either in ascending order or in descending order. So in order to keep the data in ascending order, what we have to do first, we have to copy the data and paste it as values because it is associated as a formula. Once we do that, then we can sort it from the smallest to the largest. Once we do that, then we got the data. So you will see at the end we have the highest one, then the second highest, and this way it goes. So here it is the lowest and there it is the highest. So for median, but before I explain median, I just wanted to point out one thing which I missed out, which is the advantages and drawbacks of mean. So if you talk about the advantage of mean, which is like it uses all the information about the size of magnitude. So when you are calculating the mean, you are taking all the elements, you are not leaving any of those elements. So this is one of the advantage. But what is the drawback in this? So the mean is sensitive. Why? Because once you have an outlier in your data, for an example, if you have five numbers, 1, 2, 5, 10, 1000, and once you calculate the mean, you will find the mean is like way above than, so it will lie between somewhere around, it will be less than 1000. But the problem is because of one number which is 1000 and rest of the numbers are very nominal like 1, 2, 5, those, so those numbers got impacted because of one outlier. So that is one disadvantage of mean. So in order to avoid that disadvantage, we sometimes we use median. So median becomes more reliable in certain cases. So what does median mean? Median is the value of the middle item of all the set of items. So what does it mean? Suppose you have 11 numbers. Okay. So out of 11 numbers, if you see the sixth number, so 1, 2, 3, 4, 5, first 5, and then 6 comes, and after 6 there is 7, 8, 9, 10, 11. So the first 5 and the second 5 are divided by one middle number, which is the sixth number. So that is what our median. So median tells which is the most middle number. Okay. So when you have to find the median, there are two ways to find it. So once the number of observation is odd, then you have to follow this one. So this is n plus 1 by 2 position. For an example, if you have 11 numbers in your the sample size is 11. Okay, then what you will do, 11 plus 1 by 2, which is 6. So sixth number will be of median. So the sixth number will be median, not 6 will be median. When your sample size is even, for an example, if it is 12, then how to calculate median? For that, you have to take the mean of the values of items occupying the n by 2 and n plus 2 by 2. So what does it mean? Once you have 12, the sample size is 12, then 12 by 2 is 6 and n plus 2. So 12 plus 2, 14 by 2, 7. So sixth number and the seventh number, you first you get those and then you calculate their mean, then you get the median. So we'll see it with this example. So median. So we know the number of elements are 88, which is even, right? So for even, what is the formula for median? N by which is nothing but your number of elements by 2. So which is 44th position you have to find out, and then you have to find out n plus 2 by 2 position, which will be plus 2. So you need the position for 44th number and 45th number position, you just need here. Okay, so what we can do, just have to find those. So this gives us the serial number. Now we just have to find what is the 44th number. So we can use VLOOKUP for this. Select the range 3 of 5 false. So the 44th number is second, and let's check it once. So 44th number is second, is 2, and 45th number is 3. So we got it, and then we just have to find the average, which is nothing but 2 plus 3 by 2. By 2, which is 2.5, is our median. So for this data, we have median of 2.5, which tells like at the most middle number of this 88 observation is 2.5. So instead of calculating it this way, we have direct formula for this. Which is 2.5. Fine. Then we have the third measure, which is mode. So what is mode? It is known as the most frequently occurring value. What does it mean? It means you have all these numbers, right? 0, then 1, all these numbers. So what is the frequency of occurring for all these numbers? And how many times the 0 is coming? And how many times the 1 is coming? So once you find that frequency, the highest the number with the highest frequency will be the mode. So how to do that mode? So what we will do, we just have to find the frequency, and as the numbers are repeating, so we can't take it, we just have to take the unique value. So in Excel we have a formula called unique. Then you have to refer the table which is COVID. Then you go daily, close bracket, take the false and take false and close the bracket. Now you have all the unique values. Okay, so like 0, 1, 2. Now you are interested in the frequency. For frequency you have to take the count tips. So for count tips you select the range is nothing but COVID, confirm, and then it says just the criteria is this one. So you will get the frequency for each of these numbers. See, so 0 is happening 38 times and 1 is happening 4 times, all this. So you have to find out the highest frequency. So what you can do, you can take the max of all this. Most probably it is 38 itself. So here 0. 0 is the mode frequency which belongs to 0. So 0 is the mode. Instead of calculating in this way, you have one shortcut which is nothing but mode. Okay, the right formula you can use and you can get it. But for conceptual clarity, you need to do it intuitively. Once you do it, you find 0 is the mode. So then we come to the measures of dispersion, and under the measures of dispersion, in this video we'll discuss only this one, which is standard deviation, and this is the best. This is considered as the best measures of dispersion, but still it has those drawback as mean, which is like it gets impacted by the outliers. So there are two formulas for standard deviation. The first one is this one, which is denoted by sigma. This is the population standard deviation. So we measure it, so we denote it using sigma. And second one is sample standard deviation, which we denote by small s. So if you look at the definition, it tells it is the squared root of the average squared deviation around the mean. What does it mean? Let's understand the formula. So what it tells, if you look at the numerator, it is x minus mu. So mu is nothing but our mean, what we saw. So mean, for population standard deviation, we have to take the population mean, which we already calculated. So you are summing up all the deviations from mean for all the observations first. So observation, then you are squaring them, and then you are summing them up. Okay, then what you are doing, then you are dividing it. So you are finding the mean of all those square root of the square deviations, mean of all the square deviations. Then you are doing the square root. So this is how we find out the standard deviation. So let's do it step by step. So what we do, so these are the x, what we saw in the formula, x. So all the observations are here. So we have to find the deviation from mean. So how to do that? 0 minus, we have mean 179. So once you do that, you will find the deviation. Okay, then what you will do, you will take the square. Okay, so take square for all of those. Okay, so that part is also done. Then you have to sum them up. So go down and add them up. So you got the sum. Then what you will do, you will divide it by the number of observations. So nothing but this divided by the number of elements, which is 88. If you do that, you got this number, which is mean of square. Then what you will do, you will just square root of it. It's nothing but square root this number. So 346 is your standard deviation. So I will tell you what does it mean. So okay, before telling you, so there is another thing which is, so okay, first we'll discuss about why do we do this, like why did we, okay, the first part is we are finding the mean from all the numbers, then we are no, deviation from all the numbers from reducing the mean, then we are squaring them up, and then we are adding it, doing all this. Then why do we square root it? The reason is, so first, once we reduce it from the mean, then we may get it in the negative numbers. Few of them are negative, few of them are positive, but we need to get them in a same sign. So that's why we square it. Once we square it, then it becomes positive, right? So all the numbers are positive. So as we are squaring it, to nullify that impact, we are doing the square root. Instead of doing it in this lengthy way, what we can do, we have a direct formula for standard deviation also. STDEV. So once you do this, so this gives you the population standard deviation, what we are looking at. So just take this, click on it, so you get the standard deviation. So what does it mean? The standard deviation is the measure of volatility. What is volatility? Volatility is nothing but how the data is, like how the data is moving from each other. So if you have the mean of 179, which tells, if you take the overall data, then so their average will be 179, and the 346 is the average standard deviation or average volatility, which is like what is, like from the mean, what is the average deviation of all the other numbers. So if, so next video we'll discuss about more, like we are still left with all this, like we have to discuss the variance, range, mean deviation, then the measures of location, all this we have. Okay, before I conclude it, I will show you one more thing, which is like, instead of doing all this, instead of spending so much of time on calculating all this, you can directly get it. You don't have to do anything. So how to do that? So go to data, just click on data analysis, then go to, so you will get a list this way, and then click on descriptive statistics, what we are doing here. So click on OK. So then it will ask you for these informations like the input range. So you have to fill the input range, which is nothing but this daily data. Okay, click on it, and column is fine. So it will come into a new worksheet, and then click on summary statistics, click on OK. So once you click OK, you will find a list which will have all the descriptive statistics measures like mean and standard deviation. So mean is 178 here. So how much we got? We got 178, so it is rounded off, that is why it is 179. Then the standard deviation is 37, so standard deviation is 348 for us, 346. Okay, so maybe there's some issue. Then so variance I will discuss in the next video. Then you have coefficient skewness, which is not covered in this video. Some so we have mean, so mean we already saw. So that's what it. So if you like the video, please subscribe the channel, and please use the comment section for suggestions and ask questions if you have any doubts. Thank you very much.